All right, so these are the things that we're going to do. First, we will load and then pre-process the various images, okay? And then we use the data generator to do some data augmentation over there, right? And then we train the model and we visualize the results. And we're going to use heat map to actually see where the model was actually seen, right, on the image. If you pick, for instance, an image of say an apple, which part of that image was the model looking to be able to classify that image as containing apple. So we will see that one. And then after our model is finalized, then we're going to deploy it so that we can be able to also use images that are not even part of our data set to make the predictions as well. And that's what happens in the industry. You need, if you build a model, new data sets are going to be used or going to come in, which the users need your model to be able to classify. So we want to simulate the real world scenario over here. All right. So as I said, we have fruit, then we have vegetables. Okay, so we have fruits like banana, apple, pear, grapes, orange, kiwi, watermelon, pomegranates, pineapple, mango, and so on, right? And then for vegetables, we have a lot of them over here, right? Cucumber, carrot, capsicum, onion, potato, lemon, tomato, radish, beetroot, cabbage, and so on and so forth. All right, lettuce. So you can, there are a lot of you can see that we have a lot of vegetables here more than the fruits, right? But we still want to be able to classify. If we see fruit, we'll be able to classify it as a fruit and the type of fruit that it is. If we see the vegetable, we should be able to notice that this is a vegetable and also the type of vegetable it is. All right, so that is what we're gonna do. The train data contains 100 images each, right? That is 100 images each of fruits, 100 images each of vegetables. All right, and then the test also contains 10 images each of fruit and then 10 images each of vegetables. All right, that's what we're gonna do so far. Okay, so let's get started over here. We have our libraries that we're going to use for this training, right? It's just a simple library over here: NumPy, Pandas, Pathlib, OS, Matplotlib, and TensorFlow. Okay, these are the libraries that we're going to use, right? So the first thing that we are doing over here is to set the path. Okay, whatever that we are doing here is just setting the path. Okay, so the path that we are setting the path of training, right? The path of training and the path of test, the path of validation, right? And then the image path. So once we get the training path, the test path, and then the validation, then we also add the path of the images. Okay, so if you see the first one over here, which is the path of the training, right? If we go to input, input is this. Okay, if we go to input here, okay, we go to input, then we go inside here. Okay, input, then fruit and vegetable image recognition. We go here, right? So that's how it follows. Input, you go here, and then once you go here, then you go to test, right? If it's training, then you go to training. Validation, then you go to validation. That's the path that we are setting. Okay, that's the path that we are setting. Then after that, we go into that. So if we go into, for instance, if we go into the test, right, there are a couple of we have apple, and then inside apple there are a couple of apple images in there. Okay, there are a couple of apple images in there. So if you want to set the path for, say, image_1.jpg, right, then you need to go into input, then go into fruit and vegetable, then go into test, then go into apple, then before you reach the image_1.jpg. Okay, so that's what we are doing over here. Go into input, go into fruit and vegetable image recognition, right, and then go to training. Okay, and then once you get into training, right, then you see that we have 2-star over here, meaning that we have to first go into apple before we get to the image. Okay, and then after that, whatever image name is there, right, .jpg. Okay, that's what the path is. So we are doing is the same thing for all of them. We do it for test, then we do it for validation as well. Okay, once we get the path, once these paths are set, right, once these paths are set, then we're going to create a function, right, which we are going to use to process the file. So I just name it as proc image, right, that is process image, right, which is going to contain the file path that we have set over here. Okay, the file path that we have set over. So when we pass in the file path, then it's going to go through this this thing that we have done over here. Okay, first is to loop through the file path. So the I here is representing the first file path. So for instance, the first image, okay, will be the dot split. So I'm going to split it by the /, which is in between them, so that I'll be able to access the individual images. Okay, then once I do that, then I convert everything to series, right? Because I finally want to convert everything to a data frame. Okay, I finally want to get a data frame, so I first convert everything to a pandas series. Okay, that is the file path, right? The file path, and then the name that I'm giving is file path. All right, I'm making sure that it's a string, and I'm also doing the same thing for the labels. So we will have what is called the file path and then the label, something like this. So let me go here. You have the file path and then you have the label, right? So this one was to orange, this one was to lettuce, right? So this path here is leading us, the first path here is leading us to orange. The second path here is leading us to lettuce. The third path is leading us to beetroot. The fourth path is leading us to eggplant. The fifth path is leading us to bell pepper. Right, so that's basically what we are doing over here, right? You have the file path and then the labels, right? And then we put them together, file path and then the labels, so that we'll be able to have it like this. And then we shuffle it so that it won't be like we have apples, then after apples, then we go to banana, after that we go to beetroot. Not like that. We shuffle everything, okay? We shuffle everything so that it won't be like apples should come first and then banana it should be maybe apple, banana, lettuce, then maybe banana comes again, something like that. We just shuffle it like that. All right, and then we make sure that we reset the index, okay? Because if we shuffle it, it's possible that the file path and the label, which is at say index 20, will come first, right? And then maybe index 1 will go maybe in the 50th index, but we want the index to be in order, right? Index 1, index 2, index 3, although we have shuffled it. All right, then finally we return the df. All right, so once we do that, the only thing that we have to do is to now use the function that we have created, right? And then we pass in the various file path. Remember, we've created this file path, we formed them over here, right? So we have train underscore file path, we have test, right? We have test underscore file path, and then we have validation underscore file path, right? Val underscore file path. So we just have to process those images that are in those file path, right? And then we store them in train underscore df, test underscore df, validation underscore df. So moving forward, this is the only things that we're going to use, right? We've processed them. Okay, so here I'm just printing them out for you to see, right? I just first printed these things, training set, right? And then I'm printing the number of pictures, right? That is the number of images that we have. Okay, so train underscore df dot shape is going to give us this, right, where we have 2780 training data points, right? And then the number of different labels are 36, and these are the labels that we have. Okay, all right, so if we see what we have in there in the train underscore df, we have these things. We have the file path and then the label. Okay, so this is the data set that we are going to use right after processing. All right, so here we're going to create a data frame with one label of each category, right? That is, we're going to have a data frame of we have two categories, that is fruit and then vegetables. Okay, so the first thing that I'm doing is to make sure that I drop all the duplicates that I have in my data set. Okay, so I could have a lot of duplicates in there, right, in my data set, which I want to drop. And then after I drop that, I create a copy of the train underscore df and store it as df underscore unique, right, which is not having the duplicate ones. And then I'm going to display some of them for you to see as you're seeing down here. Okay, so in order to do that, I create a subplot, right, a subplot of 6 by 6, right? That is, I have 6 rows and then 6 columns. Okay, 1 2 3 4 5 6, and then 6. This is the 6 columns, and then the 6 rows are 1 2 3 4 5 6. Okay, so that is 6 by 6, and then the size is going to be 8 by 7. That is width of 8 and then height of 7. Okay, that's basically what I'm doing, right? And then the X ticks and Y ticks, I don't want to put anything there, so you see that they are empty over here. If you want to put something there, you can put, but you can see that there are no names here and there are no names here. All right, so that's basically what I'm doing, right? And what I am doing here is I'm doing plt.imread, right, to read the images. Okay, to read the images. Thus, I'm using matplotlib to read the images from the df underscore unique. Okay, and whatever file path is there. So the first file path, which could be orange, right, which is orange, and the second one, which is, so the I, this I is just representing all the file path that we have, right? All the file path that we have. Okay, and then I'm setting the title over there. The title should be the name of the label, right? The respective label that we have. Okay, so that's why if you pick this one, the title of that one will come respectively, and the font size of it is 12, right? So you can just change it if you want, right? And then I'm using pad equals 0.5 so that you can have some spaces in between them. Okay, I'm padding each of the images, and then when I do that, it's going to help have some spaces in between one image from the other. Okay, and then finally I'm using plc.show. So that's why you see this. So these are sample of the fruits and vegetables that we have in our data set. Okay, all right. So now the second thing that we're going to do is to load the images with a generator and data augmentation, right? So here we're going to use what is called image data generator. All right, what image data generator is going to help us to do is that if you pick the images, they are not all of the same size or of the same orientation, right? You can see that some are having longer width, right, a shorter height, some are having a longer height, shorter width, right, something like that. They are not all of the same size, right? Some are diagonally placed, some are horizontally placed, and so on and so forth, right? The images are, and they are not even of the same size. So what image data generator is going to do is to help us make sure that the images are in the right proportions, they're in the right shape and all that, right? So if you see over here, right, I'm importing those image data generator. It's actually present in Keras preprocessing. Okay, so once I get access to it, I store it in train underscore generator, right? And that's what I'm going to use. And if you see over here, I'm using MobileNet underscore v2. That's MobileNet version 2, right? That's what we're going to use, right? As I said, we're going to use transfer learning over here. So we are using MobileNet underscore MobileNet version 2. That's what we're going to use over here. Okay, so once I do that, now I'm going to use that train, right? Train underscore generator that I have. I'm going to use it over here. Okay, that's what I'm using. So once I get access to the data, which is the train underscore df, right, that is flow from data frame. So flow from this data frame, right, get the images from that. That's what it basically means. Then at the x column is going to be the file path, and the y column is going to be the labels. And the size, right, as I said, we want the size to be the same, right? Not that some are big, some are very small, and so on and so forth. All right, so we setting all the size to be 224 cross 224, right? And the color should be RGB. The class mode, of course, is 2, so categorical. All right, and the batch size is going to be 32. Shuffle equals true. Seed equals 0, right? So that's once I generate some images to feed to the model, right, if I rerun the code again, I should get consistent results by generating the same images over and over again. All right, and then the image generator is also going to help us work on the rotation, right? Rotation of the images, the zoom range, the width shift range, height shift range, shear range, horizontal flip, fill mode, and so on and so forth. So all these are things that you can just play around and change them. Okay, these are the values that I've tried and they work fine. So that's why I've put them over there. But you can just try them, or you can even get rid of all of them. Right, you can even get rid of them and then use the default, because if you comment them out, it's going to use the default values that they have set for them. Okay, so if you comment them out, they're going to be used the default. All right, so we do this one now. This one we are doing it for train underscore df, right? We're going to do the same thing for val underscore df. That's the validation data. Okay, val underscore df. Then we do the same thing for the test underscore df. Okay, so the code is just the same thing, just that the data is what you are changing. Okay. All right, so once we are done with this step, right, so if you run that one, it's going to say that we found 2,780 validated images files belonging to 36 classes, right? And for we also found 334 validated image file names belonging to 36 classes, right? So that's basically what is going to give the results you're going to have. Okay, So now we're going to load the pre-trained model over here, right? So we're going to use tf.keras.applications.mobilenet version 2, as I mentioned above, right? And then the input shape, we want it to be 224 cross 224, right? And it's going to be it's going to have 3 channels because they are colored images. Okay, so they have 3 channels over there. All right, and include top equals false because MobileNet is having over 1,000 classes, but our class is just 2, right? It's going to be vegetable or it's going to be fruit over there. Okay, all right, so that's what we're going to do, and we're going to use the weight of the ImageNet that has already been training, right? And then the pooling is to be average. All right, so we're using average pooling over here, right? You can also change that one. We've already learned pooling in our previous tutorial where we talk about max pooling, average pooling. So right, in this case we are using average pooling, but you can change it to max pooling if you want, and then try to see if you will get a better results. All right, so once we do that, we store everything in pre-train underscore model, right? And then here we are setting the trainable to be false, okay, so that we will not retrain the weight, but we are going to use the existing weight. Okay, so when you do that, it's going to download it for you. All right, and the next one is to train the model, right? That's the third step, is to actually train the model. Okay, in this case, I just ran it for just 5 epochs over here, as you can see, right? So I start by setting my input, which is going to be the pre-trained model. Okay, the input is going to be the pre-trained model, and here we have the first layer to be 120 neurons with activation to be real, right? And then we are using our pre-trained model.output. And the second one is going to be 120, right? Activation is ReLU, right? And then the first one that we have loaded, right? The entire thing is supposed to be here, right? It's supposed to be here, but since we have stored everything in X, we can just put X over here. Okay, and then the output is going to be this, right? Dense, we are 36 neurons, activation to be softmax. That is the individual classes. Okay, we have 2 categories, don't be confused here. We have 2 categories, that is vegetable or fruit, right? But the classes are 36. Okay, the classes are 36. You can actually see it over here. All right, the classes are 36. Okay, so that is what we have. And then finally we use the Keras model, right? And then we have our input and then our outputs. Okay, our output is this one, right? Our output is here, and then our input is this over here, right? And then we compile and fit. Okay, and inside the compilation we're using Adam as the optimizer, categorical cross entropy, and then we are measuring accuracy, right? And then inside the fit we are putting our train images, which we have already formed above. So if you go above, you will find it over here. Train images are there, right? And then we have validation images, and then we have our test images. Okay, so that's what we are using over here, right? So we put our train images, right? And then validation is going to be the validation images. The batch size, we want 32, and as I said, I'm just running for only 5 epochs. Okay, only 5 epochs, but ideally in your own time, run for at least 10 epochs or 20 epochs. Okay, I run it for 20 epochs and you'll see significant. It's going to take quite a lot of time, right? About 45 minutes to even 1 hour to run it if you run it for say 30 minutes. For 20 epochs. All right, and then I'm adding callbacks over here, right, which I'm going to use early stopping, right? And I'm monitoring the validation loss, right? And I'm restoring best weight to be true, right? And then I'm saying that patient equals 2, so that as soon as it finds the validation loss, right, it should wait for the next 2 epochs before we restore the best weight. Okay, so if you find the best weight to be, the best validation loss, which is supposed to be the least. Okay, so here you can see this one was the best, right? This one was the least. So validation loss, when we're talking about the best validation loss, it means that the least one, right? We want the loss to be very small. So this one was the smallest one. Okay, so as soon as it finds the smallest one, it's going to wait for have patient for the next 2 epochs to run. And if it doesn't find any better, then it will just gonna stop. Okay, so that's what it is going to basically do. Now, once it does that, we are going to measure the accuracy versus, that is the training accuracy versus the validation accuracy. right? And you can see that they are actually doing well, right? Both of them are doing very, very well. They are very, very similar over here. Okay, the accuracy is around 90 something, right? It's above 90, right? It's above 90, right? And you can see the loss is very low, right? Very, very low over here, right? It's very, very, both of them are also low, and that's what we want. We want the validation loss and the training loss to be very low together, right? Not that the training loss is low and the validation loss is high. We don't want it that way. We want both of them to be like this. Okay, that's basically what we want. I can see that they are working very, very fine. So once we do that, the next one is to visualize the results. Okay, so we're going to visualize the result. So what I'm going to do is that first, let's try to make some predictions, right? Because I want to see the I want to calculate the accuracy, right? And for me to calculate the accuracy, I need the prediction, right? How it is doing, in terms of prediction, so that I'll compare it with the test to see. So that's why here I'm doing this. I'm going to create this pred, right? And for me to get that, I'm doing model.predict, okay? And I'm predicting it on the test image because we have used the validation and the training, right, to build it. Okay, if you see it over here, we only use the training and then the validation, so it has not tested the test data. So that's what I'm using to test it over here. So that's what I'm doing over here, right? And once I do that, I'm going to map the labels. Okay, that is the label with the original one to see if they actually match. Okay, that's what I'm doing over here. So I'm saying V and K for K and V in labels, right? Dot items. So if you go into labels.items, we have let me try to show you what we have in labels.items, right? Let me run it over here. Okay, so you can see that we have 0 is apple, 1 represent banana, 2 represent beetroot, 3 represent bell pepper, and so on and so forth. Okay, so that's what I'm representing V and K for. For instance, V is for 0, K is for apple. Okay, that's basically what I'm doing, because I want to be able to extract them and then compare it with the prediction, right? I want to compare it with the prediction to see if they match or not. All right, now once I do that, that's when I'll come here. Once I do that, then I go into the labels and pick only the the K, which is going to be just these names, right? Apple, banana, beetroot, bell pepper, and so on and so forth. Okay, for K in the prediction. So I'm going to get the respective labels in the prediction. Okay, the respective labels in the prediction. I represent those. For instance, I represent apple with K. Then I go into the prediction and go and see if I'll be able to find the same K in the same position as it is in the labels. Okay, so if they match, then I'll know that our prediction is right. All right, so I'll check it in predict, then I'll check it in test images. Okay, I'll check it in test images. So whatever K is in here is in the labels. I'm going to see if I'll find the same thing in prediction. And then whatever K is in the label, so the same K, if it's apple, I check. So for instance, apple, right? I check apple in prediction. Then I'll come here to check apple in test image and see if they match or not, right? For instance, if I'm able to find apple in the labels here, right? 0 for apple, okay? Then if I go into test image, then I see that 0 for apple, then I know that, okay, they are consistent, okay? But if I find 0 for apple over here in the labels, then I go into test images, then I find 1 for apple, then I know they are inconsistent. All right, so that's what I am doing over here. Okay, once that is done, now I'm going to use accuracy score to score how well my model is doing, comparing the test and the prediction. Okay, and once I do that, you see that we have 94% as this one was telling us, right? A little bit above 90%, which is 94. Okay, so that's basically what this part is doing. So the next one here is to plot the confusion matrix, right? The confusion matrix, so that I'll be able to know whatever that I did here. As I said, I'm going to match them to see if they actually match or not. So the confusion matrix here, I'm passing in, right? We have in sklearn.matrix, we have confusion matrix, right? I'm sure these things you know already, right? So we have confusion. I'm using the confusion matrix that we have imported, and I'm passing in the y-test and y-pred, right? Setting normalized equals true, and the figure size is 15 by 10. Okay, 15 by 10 over here. We have 15 and then 10 height. And then I'm putting them into heat map, and I'm getting heat map from SNS, which is nothing but seaborne. Okay, and I'm passing in the confusion matrix that I've created, and then annotation equals true, so that I'll be able to see these 0 and all the other numbers on top, right? And S tick labels, Y tick labels, right? I'm giving them sorted, right? Y test, I'm putting the Y test values over here and I'm sorting them out. All right, and then the title is normalized confusion matrix, which you can see over here. Okay, and then finally I use plt.show to show you what we have. Okay, so you can see that we have a lot of the fruit and vegetable names over here, and then a lot of fruit and vegetables name over here, right? If you see inside, you see that we have a lot of zeros, and then some places that are having 0.1 and so on, I mean 0.56 and so on and so forth. Okay, so if we are able to see apple as apple, right? For instance, apple is here and then apple is here. Okay, so let me do it like this. All right, so let's so if we have apple here, right? Apple and then apple, right? If let me use this, right? So if I trace it all the way up, right? Apple and apple is here, right? And the value over there, right? The value over there is this value, which is 0.67, right? It means that we are confident at 67% that we're able to predict apple as an apple. Okay, and I mean, if you see the diagonals, you can see that most of them are 1 1 1 1, right? Which means we are 100% confident that we are predicting them as, I mean, correctly, right? For instance, we're able to predict let's go here, let's say orange, right? We're able to predict orange, right? This one, right? This one and this one. Okay, you see that orange and orange. So at 100% or at absolute 1, we're able to predict orange as orange, right? There are a few of them that the confidence wasn't 100%, right? For instance, this one over here is 0.9, right? So at 90%, not at 100%, this one is 0.3, right? So this one, the confidence of predicting, say, sweet corn as sweet corn was very, very low, right? The same way, the confidence of predicting say capsicum as capsicum is actually very low, 0.04. Okay, and here we are not supposed to predict, here is supposed to be 000, right? We are not supposed to, for instance, predict pineapple as a beetroot. Okay, so where they meet is supposed to be 0. All right, where they meet is supposed to be 0. So if we see some of them, these ones are misclassification, right? We were predicting corn, right? Let me put it this one. This corn here is supposed to be predicted as corn. It's supposed to go here and then link to the fellow corn, right? But you can see that over here, when you saw corn and sweet corn, you see that they are actually similar, right? This corn and sweet corn are very, they look alike. So that's why the confidence level is very high over here, right? Because corn and sweet corn are very, very much alike. But if you see something like this one over here, this one is capsicum and what? Let's see, let's trace it down and see, right? And bell pepper. Okay, these ones, we are not supposed to misclassify bell pepper as capsicum or maybe capsicum as bell pepper, right? That will be a misclassification. All right, that will be a misclassification. But you can see that at most of the time we are predicting them rightly, right? That's why you have the diagonals, right? But it's very, very few of them, right, that we're misclassifying. That's why the accuracy is giving us 94%. Okay, at 94%. So that's great. That's great, right? Even though I ran it for only 5 epochs, but you can see that it's doing great. Okay, now this one here is going to show you some of the fruit and how we're able to predict them right or wrong. Okay, so as I mentioned above, if we're able to match them, right, apple as an apple or pear as pear, then we are able to say that we are predicting them right. So let's see over here, right? So here I'm showing you what the prediction means and the actual values mean. Okay, I'm setting 3 by 3 rows over here with a figure size of 15 by 15, and I'm putting nothing at the X ticks and Y ticks that is here, right? And ideally you're supposed to have those kind of things over there, right? Because it's a graph that we are plotting, and the graph y-axis is supposed to have title Excels is supposed to have title, but if you want the visualization to be nice, you take those things off. That's why here we are putting nothing over there. Okay. And once we do that, we are using plt.im read, right? As we saw earlier on, to read the various fruits, right? We are reading them from the file path, right? We are locating those URLs to the fruits and the vegetables respectively, and we are plotting them. Okay. So we are setting the title over here. We are also using 𝐼AmShow over here. After we read it, we use 𝐼AmShow to display them. Right. Then we set the title. So the title is gonna be true, and then the actual fruit or the actual vegetable name will come. Okay, so true, and then we go into the text. We find the label for the actual. Okay, and then the predicted. So we have true, right? If you see the image, you can see that we have here we have true, then we have predicted. Okay, so that's what is going to happen. So the predicted is going to have the same I, right? The same I. That is, if we pick potato, you should go and pick, go into our predicted and see the same index and pick whatever is there, right? If we pick, say, peas, right? You should go into our predicted and pick the same item at the same index. Okay, but you can see there are some. There's one misclassification over here, right? This one, right? The true thing is potato, but you can see how this thing is. This is very deceptive. It's an animated potato. So our model was not able to actually identify it. It ended up identifying it as orange, which is a wrong classification. But apart from that, right? Apart from that, if you see the rest that we have, right? Peas, we're able to identify it as peas, right? Pear, we're able to identify it as pear. Lemon, we're able to identify it as lemon, right? Turnip, we're able to identify it as turnip. Watermelon as watermelon, right? Ginger as ginger. Corn as corn. Tomato as tomato. So most of the time it's doing well, right? Unless that at times where we try to fool the model, right, by using some kind of animated things like this, right? So most of the time it's going to do well. At 94% of the time it's going to identify the right items for us. All right. If you wanted to learn from these outliers and these strange images, then you have to put more of these images for it to learn from, right? So that when it sees something like that, it will be able to identify it. All right. Now, if you build it and you realize that maybe your model is doing much of the misclassifications, then you want to see where is your model looking that it is doing misclassification. For instance, we have this pair over here, right? If your model is not looking at the entire pair, or it's not looking at, the pair here, and it's looking at some item over here, okay? Or maybe let's pick this one, right? If your model ended up predicting this one as, say turnip, right? Maybe it's looking at these things down here, right? Instead of looking at the lemon itself, right? Instead of focusing on the lemon, maybe it's focusing on these things. If you get to know like that, then maybe you can go to use the image data generator, and then you can crop them. Okay, you can crop your image, right? So this case we're using 224 cross 224. So you can just crop it so that it becomes, it takes away the noise, and then it will focus on the actual thing that you wanted to predict. Okay, so in this case, if it's looking something outside, you can go into the image data generator, crop it out, right, or reduce the dimension over there. Okay, so that now you are limiting the probability that your model will look outside the image itself. Okay, that's what you do. So in order to see where your model is looking, we have this we have this code over here, right? This couple of functions over here, one function here, another one here, right, and then another one here, right? This function is present in Keras. Okay, if you go to Keras and you search for grad-com, okay, let me just do it for you to see. Okay, you go to you just search for Keras grad-com. Okay, if you go there, right, you're going to find the same code over there, right? This same code, this is the same code. You don't really need to worry yourself about this the internal individual codes that are there. The only thing that you need to know is these functions and how to use them. Okay, and that's what you're going to use. You're going to see, right? So it's going to help you see where your model is actually focusing. Put a a heat map over there. Okay, put a heat map so that you can see where your model is looking. Okay, so for instance, in this case, in order to identify a dog as a dog, it's focusing on the face of the dog, right? Certain things on the face of the dog, right? To classify a cat, it's looking at this part of the face, right? So you can actually see what your model is doing, and if you need to do any adjustment, you can do, right? So that's basically what we're gonna do. So I'm using the same code. You don't need to do anything. You just have to copy it, and then you bring it over here to use, right? Okay, so that's it. This is the end of the code, right? This is it. And then from here, I'm creating pre-process input and then the code predictions. Well, these things I'm getting it from MobileNet, right? Inside MobileNet, we have pre-process input and the code net, which we are going to use, right? And I'm storing everything in pre-process unit and also the code underscore predictions, all right? And then here we have last conv layer name, right? Which is going to be conv1. And the image size is 224 cross 224, right? And then here we are removing the last layer, as I said, depending on the number of classes that we're going to output over here, right? So we remove the last layer from the MobileNet that we are loading here, okay? And then finally, we're going to display them. So in order to display it, I just copied the same code, right? The same code that we used in displaying is the same thing that I copied over here, right? I copied over here. Then I just added something small over here, which is this one. Okay, this is the thing that I added, right? The rest are just the same thing that you use in running this code, right? And whatever I added here is the functions. Okay, so we have get image underscore array, right? And that is what I'm using over here, right? Here you can see that I have get image underscore array. Then I'm passing in the image path and then the size, which is 224 cross 224, right? And I have the make underscore grad cam underscore heat map, which is one of also the function over here, right? It takes in the image array, the model, the last conv layer name, and then the print index, right? Which we have set to the last layer conv name and the size over here. So I just pass them in here, right? I pass in the image array, the model, and then the last conv layer, which we have decided over here. Okay, once I do that, I use the save and display grad cam, right, which is the last function over here, save and display grad cam, right? The code is nothing, it's simple, but you don't really need to worry yourself about it, right? For instance, the first one, get image underscore array, is nothing but just using the Keras preprocessing .image.load image to load the path of your image and the text size, right? And then preprocess your image, right? And then you set the dimensions and you return the array. That's it, right? It's not anything big, but you don't need to worry yourself about that, right? You just have to use the function as I am using over here, right? Next time that you meet any other problem, you can just make the respective changes, right? Without you worrying about the internal workings of that. You just have to use the functions as I am using here, okay? And then finally, I'm using plt.iread to read all the images, okay? And then I'm using IAMShow to show them, setting the title respectively over here for the true and also for the predicted, as we saw earlier on. So you can see this one that it is making mistake. It's not even looking at the entire thing over here. It's just looking at some small part over here, right? Some small upper part over here. You can see that's the part that is highlighted, okay? So that's why it's predicting that it's orange, because if you take only that part, it's going to look something similar to orange. You see this one that it is predicting it, right? You can see that this is the focus. This is the area of focus. Okay, here you can see that it's focusing in this area. Okay, so of course, a larger proportion of the pair is inside, so it will be able to predict it. Okay, if you see, let me do this one. If you see the orange, right, it's actually focusing on the orange itself. Okay, it's focusing on the orange itself, right? Just some few distractions over here, but you can see it's actually focusing on them, right? If you see the ginger, for instance, you can see why it is really focusing. Okay, it's really focusing on the ginger. That's why it will be able to predict it correctly, a ginger to be a ginger. All right, so that's basically what you do with respect to seeing where your model is looking. So if I don't like what this one is doing, probably I can augment it, right? I can just maybe crop the unnecessary part and also stretch the image a bit, or maybe use the orientation, right? We have orientation in there. If you go to data image generator, right, you see that we have horizontal flip. So I can just flip it, right? I can just flip it so that the model will now focus on it. Okay, so that's basically what you do when you want to identify where your model is actually looking. Okay, so now the last one that we're going to do is to actually load some of the images and see if we'll be able to use our model to predict them right. Okay, so I'm setting the I'm creating a function here called output. Okay, I'm creating a function here called output, which is going to contain the location or the path of the image that I want to use. Okay, and I'm using here, since it's a function, I need to make sure that the particular library that I'm going to use. So I'm going to use load underscore image to array. These two models are the ones that I'm going to use over here. So here I use load underscore image and I pass in the location. Remember, this is just a function, so I just need to put a name there. When I come here all the way here, I'll just call that function, right, the function name. All right, and then the rest of the things are going to run. All right, so once I load the image, right, I set the target size to be 224 cross 224 in 3 channel, right, and then I use image to array to convert the image to an array, right, and then I normalize it, right, since some of the images are going to have high array values and some are going to have very low array values, right? So I make sure that they are between 0 and 1 by normalizing them. Okay, and then I use expand dimension also over here to get the right dimensions of the image. And then finally I do the prediction, right? I feed the image to the predict function, right, which I'm using my model over here to predict. Okay, so once you do that, I'm storing everything in the variable called answer. Then I do answer.argmax, store everything in y underscore class. And once that is done, I'm just going to store all the classes that are in y class that I've able to get, right, in just a variable called y, and convert everything to an integer. Then I find all those classes that I've been able to predict in the labels and store them in results, right, which I've shortened into res, and then I finally return the res. Okay, so this is just a small function which will help us to make the prediction. So the only thing that we need to call here is the output. Okay, so here I'm just displaying the image that I want to predict. So this is the image of a cabbage. Okay, so I read that cabbage image. I actually got it from here. Let me collapse these things, right? I got it from the validation, right? If you go into validation and you go to cabbage, right? If you go to cabbage, I just pick this first image, right? If you click on that, you see that that's the image. Okay, then that's what I'm using. That's what I put. All right, that's the path. I have to go into input, fruit and vegetables, go to test, right? Go to test, right? So this one I'm getting it from the test, right? If we go into test and then you go to cabbage. If you go to cabbage, okay, that, right? So go to test, go to cabbage, and then go to image 1. Okay, and then I just store it as a location, right? That's the location of the image. And then I'm using display, right, and then image.open, which is going to help you display the particular image. Okay, if I change it to 2, right, it's going to display whatever 2 that is here. Remember, I have shuffled it, so that's why you're seeing these things. If I put 2 over here and I run it again, it's going to display that image that is there, which is at that image 2, right? Okay, so this is the second image for cabbage. Okay, this is the second image. If we put 10 over here, it's going to display that 10th, that cabbage which is there, which is image 10. Okay, that is something like that, right? It's just a duplicate one. If I put, say, 7 over here, okay, so this is the image at 7. All right, so you can just do it. And then use different this one I'm just using cabbage, but you can use pepper, any type of pepper, any type of beetroot or banana, whatever that you want to use. Okay, the only thing that you have to do is to make sure that you get the right path and you store it in location, so that when you come here you just call the function or so output and then you pass in the location, right? So that everything that we've created in this function is going to run. Okay, when you call this output, okay, you call the output, you pass in the location, and that's it, right? So once I do that, you see that it's predicting that it is cabbage. Okay, it's predicting that it's cabbage. All right, so finally, the only thing that you have to do is to make sure that you save the model. So I'm doing model.save, then I'm giving it a name as fruit model.h5. Okay, so if you go to the deployment part, right, the code that we are going to use for deployment, you will see that we have that one over there, fruit model.h5. That's just going to be the model that is going to run behind the application that we're going to create. Okay, so you make sure that you save it, model.save, and then it's going to save, right? If you save this model, you can find it over here, right? Let me collapse these things. You can find it here, which is, and the output, if you open this one, right, go to more, right, let me just refresh. Right, you see that is there, fruit model.h5, and then you can go to the three dots here and click on that, and you can just download it. Okay, that's what we have, and that's what you're going to use going forward. Okay, so I hope you have enjoyed this tutorial, right? So just have time and recreate it, right? Like I showed you how to do this thing from scratch. So you can just have time and then create it from scratch, or as I showed you, you can just click on copy and then copy and edit, right? You can click on copy and edit, or edit my copy or something like that, right? And then you can just work as alongside. So I hope this one is more understandable. In the next tutorial, we're going to see how we can deploy this, right? Because we're going to see how we can deploy this one in production. All right, so see you in the next tutorial. Have a nice day.